Hi, welcome back to Statistics 1. The topic for today's lecture is mediation analysis. In the last few lectures, we've covered in detail multiple regression analysis. At first, we covered multiple regression analysis sort of conceptually, and how to interpret regression coefficients when there are multiple predictors in a regression equation. Then we walked through the matrix algebra that allowed us to estimate the regression coefficients with multiple predictors in one equation. What we'll do in today's lecture and in the next two lectures is look more closely at specific types of multiple regression analyses that are particularly popular in the social sciences. So today in lecture 10, we'll do mediation analyses. In the next lecture 11, we'll do moderation analyses. And then in lecture 12, we'll do both mediation and moderation together in R. So the focus for today is mediation analyses. And this lecture is organized into two segments. In the first segment, I'll take what's called the regression approach to doing mediation. And in the second segment, I'll show you what's called path modeling, or the path analysis approach. But for this first segment, we'll just do the regression approach. So to do mediation, I first want to make this distinction between mediation and moderation, because I've taught this topic many times, and this is a popular topic, particularly in my graduate level class. So I sometimes don't get to this in an introductory class, but I wanted to cover it here in Statistics 1 because it is both are such popular methods. So I teach this often at the graduate level, and a lot of graduate students have trouble differentiating mediation and moderation. They'll often get confused in their head which type of analysis is appropriate for the type of design or for the type of hypothesis they want to test. So let's just, at the beginning, make clear this distinction between mediation and moderation. So as I said, today we'll talk about mediation, next lecture, moderation, then we'll do both of them together in R. So to make the distinction, I have these nice two images. One, just think about what the word mediation or what a mediator means. So what this image depicts is here in the middle, you see a person who's a mediator. They're communicating in between these two people who may have a dispute, and this person in the middle is mediating the relationship between the two people on the sides. Statistically, what we'll do is we will look at two variables that may be correlated, let's say. So like x and y, we've done a lot of examples like that, where we've looked at the correlation between x and y. And we'll see if we can find another variable that, and I'll call that m, that mediates the relationship between x and y. If so, then we might be able to say something about the mechanism that links x and y. And that's why this is such a popular method in the social sciences, because a lot of areas in the social sciences, they have to rely on these observational studies. They can't do randomized experiments. So there's this problem of trying to infer causality from correlations. If we can show mediation, that gets us one step closer to getting at a stronger causal argument. It still doesn't get us there if it's purely correlational, of course, but it helps. Again, distinguish that from moderation. Here you see a picture of someone who's the moderator down at the bottom of the image. The moderator sort of controls the entire conversation. So the moderator can just sort of immediately impact one person on this distribution of people. Same thing with statistically and relationships among variables. So if we have, say, x and y, and say these are correlated, the moderator can just zap that. The moderator can say, nope, it's not correlated under my roof, or it can say, hey, I'm going to enhance that correlation. I think it's really important. So the moderator has influence or control over another relationship. So again, a lot of graduate students get flustered about this mediation analysis, moderation analysis, and in my opinion, they make too much out of it. So I go back to this nice little acronym that my high school soccer coach used to yell at us. So keep it simple, stupid. Whenever we sort of made too much out of a play or thought too much about something, he would always say, use the KISS method. Just keep it simple, stupid. Use the KISS method. Again, we're only dealing with 4 variables here. That's not that complex. You'll see we're going to get into designs later in the course that have a lot more than 4 variables. If you go beyond statistics 1, you're going to deal with much more complicated data sets. We still only have 4 variables at most. And in this mediation analysis, all we'll have are 3 variables. So keep it simple. There's just 4 variables. I'll use X and Y as I have been for the predictor and outcome respectively. In the example I'm showing in this segment, I'm just going to use predictor and outcome, but keep in mind that these could be, X could be an independent variable in the true sense that we could have a randomized experiment and we could do mediation analysis on that. And we'll do that in the lecture where I demonstrate mediation in R. But for now, we'll just keep them as predictor and outcome. I'll use M for the mediator and Z for the moderator variable. So the example we'll use in this first segment is, let's say X is some psychological trait, say extroversion, and it's correlated with happiness. And this is actually true in a lot of studies. You see a positive correlation such that people who are more extroverted also tend to be more happy on different types of scales. So what's a possible mediator or mechanism of that? Now, I just made this up and I just made up the data. I simulated data in R. So one possibility is that the mechanism is just diversity of life experiences. So if you're extroverted, you might just have a wider range of experiences, more diverse range of life experiences. So those would be positively correlated, and that in turn would cause you to be more happy. What we'll do in the next lecture, we won't touch this variable today, is we'll consider a moderator variable on that relationship. So perhaps socioeconomic status moderates that relationship. So I've sort of painted this picture here where I'm saying, well, maybe extroversion is positively correlated with happiness, but maybe that's only true at higher levels of SES. Maybe at lower levels of SES, extremely low levels of SES. If you're extroverted and you have a diversity of life experiences, they might be negative life experiences and they might lead to lower happiness. So socioeconomic status might moderate that relationship, not mediate that relationship. Okay, so to the mediation analysis, as I said, it's typically conducted when we know we have a correlation between X and Y, but we want to know more about why that correlation or why that relationship exists. Can we come up with some sort of mechanistic explanation of why those variables are related? And we know from just simple regression a few lectures back that if X and Y are correlated, then we can predict Y from X, and here's the simple regression equation. Now, if we add in a mediator variable, we will actually wind up with 3 regression equations. Here I'm just going to show you 2. So we have our first one is we can predict Y from the mediator variable. And secondly, we can predict the mediator variable from X. So the first regression equation, what I'm doing is just picking off this piece. I'm saying we can predict Y from the mediator. And with the second regression equation, what I'm showing you is picking off this piece, is we can predict the mediator from X. But to include this entire sort of path diagram, and that's what we're going to see in the next segment, what we need to do is add in both predictors into one regression equation. So here's the full model, so to speak, is it has both the mediator and the original predictor. So the question is, what happens to the predictive validity or the predictive value of x after you add in the mediator. If x and y are correlated because of the mediator, as I've said here on this slide, then x should no longer be significant because the mediator will explain all the variance in y that x was accounting for. So that predictor x should no longer be a significant predictor of y. So down here, to answer the question, the regression coefficient B2 should no longer be significant if there's full mediation. It's possible, though, that B2, the regression coefficient for x, it's possible for it to still be significant, but to be of a smaller or weaker value than it was originally when it was put into the regression equation by itself. In that case, we'll have evidence for partial mediation. So there are really three possible outcomes when you do a mediation analysis. You might see no evidence for mediation, or you might see evidence for full, but you also might see evidence for some. And I'll show you an example of that. And again, I just want to put in red letters here, caution. I'm going to start drawing these path models in the next segment with arrows that typically depict causality. But again, at least in this example, we're just dealing with correlational data. So the mantra still applies. Correlation does not imply causation. And I like to put in here in my graduate level class, there's a big difference between statistical mediation and true causal mediation. So we might have evidence for full mediation in a statistical sense. But if we're just dealing with cross-sectional correlational data, it doesn't mean we can say anything, make any strong arguments about causality. Okay, so how do we actually test for mediation? How do we implement this? Well, we want to run 3 regression models. And again, we'll do this step by step, and we'll write a script to do this in R in lecture 12. But for now, I'll just go through this quickly. These are the 3 regression equations you'll run. Again, LM is the function, and R stands for linear model. You do one that just shows you the direct relationship between x and y. Obviously, there has to be a relationship to mediate, right? Then you want to make sure that the mediator and x are related. And then you do this full model. And the question is, what happens to the predictive validity or the predictive value of x after adding in m? So to get full mediation, what we'd like to see is first in the first 2 simple regression equations, obviously we want x to be a significant predictor. That has to be for us to just do a mediation analysis in the first place. As I said, we have to have x be a significant predictor of y. We have to have it so that x is a significant predictor of m. Those just have to hold. We wouldn't engage in mediation otherwise. With this last regression equation, m should be significant. It's sort of up in the air as to what's necessary for x. As I said, if x becomes non-significant as it approaches 0, that's evidence for full mediation. That means the direct effect of x has just gone away completely. But x might remain significant even in the face of a significant mediator, and that would be evidence for partial mediation. So let's get back to the example and see some numbers, see this in action, and let's make it more concrete. So as I said, I just made up data in R, so these are simulated data. Assume we had 188 subjects. So this is a nice big sample. We surveyed them. I'm leaving out the socioeconomic status for this lecture. That'll come in next lecture. So right now we just have 3 measures: happiness, extroversion, and diversity of life experience. Assume all of them are just scored on a simple scale, 1 to 5. Higher means happier, more extroverted, greater diversity of life experience. So we're assuming all of these to be positively correlated. In the first two simple regression models, here are the results. So when I'm predicting happiness from extroversion, the unstandardized regression coefficient is 0.28. So again, what that means is for every 1 unit increase in extroversion, I'm predicting an increase of 0.28 on the happiness scale. And if extroversion were 0, then I would predict 2.19 on happiness. So let's take someone with an extroversion score of like 4. That would be, 4 times 0.28 is a little over 1, plus 2.19 would be about 3.3, 3.4. So if you're high on extroversion, you'd be a little bit higher on happiness, or your predicted score would be. They're positively correlated. And same thing for diversity of life experience. So the first two conditions hold. X is a significant predictor of our outcome, and it significantly predicts the mediator. Now let's look at the full model. That's down here. And what we see is that both extroversion and diversity of life experiences, both of those regression coefficients are significant. And if you compare them to the regression coefficients when they are entered by themselves in the simple regression models above, they don't drop very much. Okay, so extroversion went from 0.28 to 0.22, and diversity, I don't have the other one, we went down to 0.19. So the slopes of these relationships between the predictors and the outcome, they don't drop much from when they're entered in by themselves as predictors. So what we're seeing here is evidence of partial mediation, because that direct path didn't drop all the way to 0. It actually only dropped a few points. So it went from a nice positive slope to just slightly less than where it started. So the interpretation of this result is, if I go back to the equation, extroversion and happiness, they're positively correlated. Diversity of life experience only partially mediates that relationship because this value here, 0.22, only dropped a little bit from 0.28. If it had dropped to 0, that would have been evidence of full mediation. So what we'll do in the next segment is I'll go through that example again, but we'll do it in path model form, and I'll show you all of that graphically, which actually helps to sort of understand and see the relationships. You'll see it in models, which I prefer. So we'll go through that example one more time in a path analysis approach, and that'll be the topic for the next segment.